This booster launched the United States into a new era of exploration. Saturn launched Apollo. Apollo reached the moon. And this rocket was expendable, as were all our boosters. But even as Americans were on the moon, NASA centers were developing the technology and materials, aerodynamics, high-pressure engines, thermal protection, cryogenics, and structures that would lead to a new space vehicle. Enterprise, the first orbiter vehicle of the nation's new space transportation system. A system that is not expendable. It is a marriage of rocketry and aeronautics, one that will open up flight into space as routine, and at about 1/4 of the cost of launching today's booster systems. It will begin at the Kennedy Space Center in 1979, the effort of over 45,000 Americans. An orbiter like Enterprise will be launched as the first space shuttle. Later flights will be launched from here and from the West Coast, from Vandenberg Air Force Base. The system consists of the orbiter, its 3 liquid propellant main rocket engines, 2 solid rocket boosters, the external tank with fuel for the main engines. The main engines and the solid boosters fire simultaneously. The 2 solid rockets burn out and separate to parachute into the ocean. They will be recovered and later used again. Now the main engines are cut off, and the external tank is jettisoned. The tank will fall into a remote ocean area. It is the only expendable element and will not be recovered. The orbital maneuvering system is fired. The space shuttle goes into orbit. The orbiter operates with a crew of 3 and can carry up to 4 additional passengers, scientists, engineers, physicians. The space shuttle is not limited to any particular mission. It has many, both civil and military. It will be used to place payloads in low Earth orbit, to retrieve satellites, to serve as a space laboratory, and through space-launched solid rocket upper stages, the interim upper stage and the spinning solid rocket upper stage, it will send payloads into high-energy and Earth escape orbits. The use of Space Shuttle as our primary launch system eliminates the need for many different U.S. space launch vehicles and their various facilities, now in current use for space flights. The orbiter can deliver up to 65,000 pounds of payload in its 15 by 60-foot payload bay. The international uses of our satellites like Landsat have been enormous. Space Shuttle can have an even greater impact. The request for international applications will parallel the demand for United States airframes our industry now enjoys. Re-entry into the atmosphere begins with the orbiter positioned in a tail-first attitude. The orbital maneuvering system engines are fired, and orbital speed is decreased. The Space Shuttle begins to descend from orbit. Reaction control system engines are then fired to place the orbiter into a nose-forward, high angle of attack position for final re-entry. The orbiter's heat shield protects it from the high heat encountered during re-entry through the atmosphere. Cooling occurs at lower speeds. The orbiter will return to land at the launch site in Florida or California. It will glide to an aircraft-type landing on a conventional runway. A procedure turn to the final approach is made near the landing site. Now the landing gear goes down on final approach to the 3-mile-long runway. Airspeed, about 200 knots. After about 2 weeks of checkout and payload installation, the orbiter will be ready again for another flight. The orbiters, under project management by the Johnson Space Center, are assembled here at Rockwell International's plants in California, Palmdale, and Downey. The nation's new space transportation system is the result of work of over 200 companies in almost every state of the Union. Work on the second orbiter is underway and on schedule for delivery to Kennedy Space Center in 1978. September of 1976 saw the rollout of Enterprise at Palmdale, California. The first flight tests within the atmosphere with Orbiter 101, Enterprise, and this Boeing 747 as the carrier aircraft will take place in 1977 at the Dryden Flight Research Center, California. These tests will be designed to prove the orbiter's landing systems and its handling characteristics at low altitude and low speeds. The main engines under management by Marshall are manufactured by the Rocketdyne division of Rockwell International, Canoga Park, California. Engine demonstration firings are being conducted at NASA's National Space Technology Laboratory, Bay St. Louis, Mississippi. The engine uses liquid hydrogen and liquid oxygen and will produce 470,000 pounds of thrust. At NASA's Michoud Assembly Facility in New Orleans, Martin Marietta, under direction of Marshall Space Flight Center, is developing and fabricating the external tank. It is over 155 feet long, the diameter 27.6 feet, and it carries about 225,000 pounds of liquid hydrogen and 1,325,000 pounds of liquid oxygen. The solid rocket motors are developed by Thiokol Corporation for Marshall Space Flight Center at the Wasatch Division, Brigham City, Utah. Thiokol will static test the first development motor in mid-1977. Each booster will provide 2.5 million pounds of thrust at launch. The boosters are 150 feet long and nearly 12 feet in diameter, some 65 feet longer and 2 feet wider than this test booster. The Space Shuttle is also an international program. Space Lab, a self-contained laboratory, is being developed by the European Space Agency, with 10 countries participating in its funding. The Government of Canada, through the National Research Council of Canada, is developing and funding the orbiter's payload handling mechanism, the remote manipulator system. This runway, 15,000 feet long, nearly 3 miles, is at Kennedy Space Center. Another will be constructed at Vandenberg Air Force Base on the West Coast. The immediate result of Space Shuttle will be that it will provide the United States with easy access at low cost into and out of space. In the future, perhaps, these scenes will be a reality and not just an artistic concept. The cabin environment in the working and living areas is shirt-sleeve. By the 1980s, there will be a period of scientific and commercial utilization of space. Satellites to aid in the study of advanced communications, mapping satellites, navigational, agricultural, astronomical satellites. Beyond this initial period of use, the space transportation system will open vast new areas of development in space. Power reflectors, arrays of solar panels, solar power stations, multi-beam communications antenna, on station, satellites for mail transmission, nighttime illumination for our cities, satellites to warn of earthquakes. Our manned space effort, through projects Mercury, Gemini, Apollo, and Skylab, has advanced the United States in space. The future uses of the Space Shuttle, the space transportation system, are limited only by the scope of our imagination and by our daring.